Up until this point, we have seen different data types. For example, if we wanted to define a number, we could easily say integer number is equal to 5, for example, or maybe a boolean, double, strings. We have seen all of them, but what if we want to define our customized data type? For defining your customized data type, you can use classes in Java. Let's create a class and we will continue our talk in there. For example, what if you want to define a new phone or maybe a computer? For that, you can use classes in Java. Let's create a class and later on we will talk about it. Switch to this Android view to make sure that you are at the same place that I am right now. Go to Java folder and on your package name, the first one, right click and in this new panel, create a new Java class. In here, you need to name your class. Once again, you can't use things like spaces and weird characters. I'm going to create a font, so I'm going to name my class font. Leave everything else as default and click on OK. This is the general schematic of a class in Java. It lives inside a package, which you can see up in here. It has a name, which my class name is phone in this case. It has the keyword class in itself. And also it has an access modifier, which we are going to talk about in a few minutes. Like real-world objects, classes in Java have different properties and different behaviors. For example, if you take a look at the objects around you, for example, your phone has some properties like a screen size, a memory RAM, and also something like a Bluetooth. And also it has some behaviors. For example, you can call with your phone, you can play music, and everything. Classes in Java have behaviors and properties as well. For example, we can set different properties for our class inside the curly braces of our class. For example, I can define a new screen size for my phone. Notice that in here I'm not going to initialize the values because we are going to reuse this class over and over. And later on, at the time of initializing, for example, from our main class, we are going to set the different properties for our object. Our phone can have a name, for example, let's say a string name, and also it may have a memory RAM. Also, we have camera, for example, 5 megapixel or whatever. These are the properties, or as we might call it, the state of your class. Also, we call them the fields of our class. Notice that the fields in your class can have an access modifier as well. For example, in here I can put a private, or like my class I can say public, but more on that in few minutes. Also, you can set different behaviors for your object. For example, if I want to play a music, I can create a method. You define your class's behavior by defining a new method. Let me create a method and I will talk about it. Every method in Java has a name, which in my case is play music. Also, it has an access modifier like the class and fields. I will talk about it. Also, our method can return something. For example, if I put int in here, the return type of this method would be an integer. I can have different data types as the return type of my method. For example, a string or maybe the class itself. Sometimes you don't want your method to return anything, you can pass void. It means that your method won't return anything. Also, a method can have one or multiple inputs, and you pass your inputs via these parentheses. For example, in here I'm receiving a string called track name as the input type of my method. Later on, we will see how we can pass different strings or maybe other inputs to this method. And inside the curly braces of my method, I'm just simply printing something indicating that my phone is playing some music. Okay, let's see how we can initialize our object and also set different values, for example, for our fields and maybe call different methods for our object. The start point for my code will be this main method in here. So I'm going to initialize my phone in here. Like a string, I can type phone And IntelliJ is smart enough to know that phone is a new class in Java, which I can use it as a new object. Notice that every object, every class in Java has a package. As you can see in here, it lives inside org.makecode.oop session1. You might see different versions of your object. For example, this one in here, it lives inside another package. But the one that I want to use is the first one. So make sure to import the right one. I can say phone, let's name it iPhone, is equal to a new phone. This is how you can define your objects in Java. With the help of this new keyword in here, you are creating a new object. But how can we set different fields for our object? I can simply say iPhone dot. With the help of this dot operator, I have access to all the fields and methods of my class. For example, I can say iPhone.name is equal to, let's say, iPhone X. And if I want to have access to the name of my object and print it, I can simply say print iPhone, or let's say name plus iPhone.name. As simple as that. If we try to run our application, we should see the name of our object. Seems like our code is working fine. Also, you can call different methods of your object from this main class as well. For example, I can say iPhone dot play music this time. If you take a closer look at the icons in here, little f means the field of your class, and also m means the methods of your class. By selecting this one, I know that this one is going to be a method. I can call my method from here, iPhone.playMusic, and inside the parentheses, I need to pass the track name and the input type of our method from our class. And if you want to know for sure that what you need to pass to these parentheses, you can press down the control key in Windows and hover over your method. You can see that we need a string called track name. I believe in Mac it should be pressing down the command key and hover over your method. Okay, let's pass a string in here. For example, I'm going to say lamenting keys. Once again, if I try to run my application, I should see that music is playing lamenting keys. You might wonder what is the use of methods in Java. Well, methods are useful for organizing your code. For example, if you have tens of classes, you don't want to have a messy code, so you need to define methods in the right place. And also, you can reuse methods. For example, if I want to play music from different parts of my application, my phone, I can just easily call this method and pass the track name. Also, it's a good point to say that in your application, you can't call your methods more than, I think its number is 65,000 times. It's a huge number, but sometimes in large applications, it can reach to that number. But don't worry about that 65,000 number. If you have a larger application, you can use something called multidexing, which allows you to have applications that calls methods more than 65,000 times. Okay, now let's talk a bit about our access modifier in here. I can have access modifier for my fields as well. For example, if I put private in here, this field is going to be private inside this class, and I can't use it, for example, from my main method. For example, if I change the access modifier of this name in here to private, if I switch back to my main class, you can see that it's giving me a red warning. It means that it's a compile time error, and your code won't compile if you try to run that. Whenever you are using access modifiers for your fields and methods, that field and method would be only accessible from your class and not outside of that class. It's useful for some reasons. The first one is, I think, the security reasons. For example, if you have multiple users, you don't want all of your users to have access to the fields of your phone. Later on, we will see how we can access to these names, even though the access modifier is private. But for now, just know that whenever you put private at the beginning of your field or method, that method or field would be accessible only from your class. But if you don't put anything, it's equal to a public access modifier. For example, if I put a public in here, it won't be different from this memory RAM. Both of them have the same access modifier. The other access modifier is protected. I will talk about that in future videos, but for now we are just going to work with public and private. Okay, let's see how we can overcome the problem with accessing, for example, this name from other classes. Well, you can define a method down in here inside the curly braces of your class. It needs to be public because you want to have access to this method from other classes. The return type of this method is going to be void. We are not going to return anything public, void, set name, for example. As you can see, IntelliJ is suggesting me a list of names. It knows that most of developers use these conventions for their name, so it's suggesting me different names. The one that I want to use is this set name method. As the input of this method, I need to receive a string. Let's call it name, a pair of curly braces, and inside the curly braces, I can say name. I'm going to refer to this name up in here is equal to name. But it's not right because right now both of these names are referring to the name that we are receiving as the input. But if you want to have access to the fields or methods of your class, you can add another keyword at the beginning of the name of that variable or method. That keyword is this. By typing this dot name or the name of your variable or method, it will access the fields or maybe the methods. And if you take a closer look, you can see that both of these names has been highlighted. It means that it's referring to these two variables. This keyword in here is referring to the current object that you are in. Because we are inside some class in here, this keyword is referring to the current class, which is phone in this case. Later on, we will see that you can refer to the interface and other things as well. But for now, we only need to know that this will refer to the current object. But what does this line of code mean? I'm setting the name from up here to the value that I'm receiving via inputs of this method. Later on, for example, from my main class, I can call that method. Let's delete this line of code. I can say iPhone dot the set name method. I need to pass a string name. Let's pass iPhone X. This way, we are getting around the problem that we had with this access modifier. We can set different values for our fields, even though they are private. But how we can get the value of the method? As you can see in here, I also have another red compile time error down in here. For that, I can create another method in my phone class. Once again, it needs to be public. This time, the return type needs to be a string because I'm going to return the name of my phone. So public string, let's call it get name. Once again, IntelliJ is suggesting me the name. Get name. This time I don't need to pass anything as the input, a pair of parentheses. And the way that you return something from your class is by typing return. And the way that you return something from your class inside your method is by typing this new keyword, return. This is exactly doing as it means. It's going to return something. For example, I'm going to return this dot name. Once again, this refers to the current object. I need to end my sentence with a semicolon, and later on, for example, from my main class, instead of iPhone.name, I can say iPhone.getName this time. I'm going to use that method. Okay, let's run our application and see if it's working fine. As you can see, once again, we have the same result. Let's minimize this pane in here to have a little bit more room. The benefit of using setters and getters is that you can grant some privileges, for example, for different users of your application. One might get the name of some field from your object, but one might not change the name of that phone, for example, or vice versa. Okay, let's create getters and setters for other fields as well. outside of the curly braces of your method and inside the curly braces of your class, I'm going to create those getters and setters. One way is to define them like this, or you can right click and go to the generate in here. As you can see, the shortcut is Alt Insert for Windows. For Mac, you can check the related shortcut. Click on the generate and click on getter, setter, or maybe getters and setter together. I'm going to click on getters and setters, select all of them and click on OK. As you can see, IntelliJ has generated a lot of codes for me. If you take a look at some of them, for example, this set camera is exactly like we defined the getters for our name or setters for our name. You can use the help of IntelliJ to generate these boring codes. Okay, let's set different values for the fields of our class. For example, I can say iPhone.set camera, let's say 8 megapixel, iPhone.set memory RAM to 8 megabytes or gigabytes, I think, iPhone.set screen size to 5 inches. This is one way of setting different fields for your object. The other way is to create something called a constructor. Let's go up to the beginning of my class before this method. Inside the curly braces of your class, you can right click once again and click on the generate. The first one is a constructor. Click on that and select all of them and click OK. Once again, you can see that IntelliJ has created this code for me. This is the general schematic of a constructor in Java. The constructor is the first code that will be executed at the time of initializing your object. It needs to be public. You can't use private as the access modifier of your constructor. Its name should be equivalent to the name of your object. The return type is a phone. And later on, inside the curly brace, you are setting different values for your fields. Let's also change the access modifier of all of these to private, because we have the getters and setters. But if I go back to my main class, I should get some warning in here. Because this new phone right now needs some information. For example, the screen size, the name, memory RAM, and camera. Once again, you can press down the control key in Windows or command key in Mac and hover over your method. You can see the different data types that are needed. Let's pass those data to the method. The first one was a screen size. Once again, I'm going to say 5 inches. The next one was the name. I'm going to say iPhone X. You need to separate different data via using a comma. The third one, I guess it was memory RAM, which I'm going to use 8. And also we had a camera, which I'm going to stay with 5. Let's minimize this project pane as well. Now that I have initialized my phone this way by using the constructor, I don't need these setters. I can delete them easily. And if I try to run my code, it should work the same as it did before. You can see that it's working fine. Also, it's a good thing to say that your object can have multiple constructors. For example, by right-clicking and going to generate constructor once again, you can select whichever you want. For example, I'm going to select the memory RAM. Press OK. And this is another constructor for your method. But if you take a closer look, this one is somehow highlighted, but this one is not. It means that we are using the first constructor and we never used the second one. As you can see, the warning constructor is never used. Let's define a new phone and use the second constructor. This is the beauty of object-oriented programming. You define your object once and you can use it as many times as you want. For example, I can say phone, let's call it pixel, is equal to new phone. This time I'm going to use the second constructor, which would receive only the memory RAM. Let's say 16 in this case. You can see that I'm not getting any red warnings because I'm using multiple constructors for my class. And if I want to print the memory RAM for my pixel, I can say RAM plus pixel dot get memory. Let's try running that. You can see that it's working fine. Okay, I think that's a good point to stop the video in here. In the next video, we will continue our discussion on object-oriented programming. It's going to add a lot more to our knowledge of object-oriented programming, so stay tuned for the next video. Thanks for watching and see you in the next video.